So today I will speak to you briefly about what we are doing in robotics at Essex. Uh, so today's menu. So I'll first start with the story of Betty. You will know who Betty is in some time, and I'll use this to kind of tell you what are the present challenges in robotics. After that, I'll just give you a quick taster of robotics research at Essex. And then I will go into some of the things which we are actually working: robotics in agriculture, robotics in healthcare, robotics in manufacturing. I just tweaked the name manufacturing to put Turing, or bringing intelligence into the manufacturing sector, National Center for Nuclear Robotics. And finally, I'd like to end with a different perspective, which is using robots as tools to understand how the brain works. So it kind of combines between natural intelligence and artificial intelligence. Okay, so how these two things can come together in some way. Uh, so let me just start with the story of Betty. So this was a very old event. I think happened sometime in 2002, and Betty was faced with a strange problem. Okay, so her dinner basket was trapped in a vertical tube. Okay, and she was faced with an uncertain situation: how to get my dinner. And this is what she did. It's a very old video, I think 18 years old. Probably some of you have seen it. But the question which I wanted to ask with this story is, imagine what if Betty was a robot instead? And if I were to build a robot which could mimic such kind of behavior, what are the problems we need to solve? So I'll just tell you some. Usually I like this to be interactive, but we can go for the questions at the end. We need to solve perception, not just labeling objects like this is a wire, this is a tube, but actually understanding the scene. Inference, to predict that I cannot realize my goal, I cannot get my dinner. Memory, she recalled some past experiences of playing with twigs and wires, which are natural to the habitat of these crows. Fine manipulation, which is a very difficult problem in robotics, but you can see that she created a hook-like tool using her beak. Some knowledge of cause-effect relations, that if I create a hook-like tool and pull it up, then my dinner basket will come up. Okay. And integration, which is the magic glue which connects all of these things together. Okay. So I wanted to start with this story because these are the tricky problems which we have to solve in traditional robotics. And why we need to solve this is because the constantly changing real world is full of such problems. Okay. And the robotics research at Essex kind of covers this broad spectrum: perception, inference, memory, manipulation, causality, and bringing everything together in a software and a hardware framework. Okay. So the research horizon, in our lab, we usually call it as above, below, and around. So anything that is above, underwater, or around us, we are interested in working with it. So this includes collaborative robots, drones, underwater robots, industrial robots, nano robots. And I'll just give you a quick description of the kind of projects which we are doing. So the research horizon is above, below, and around. It's a simple word to kind of describe what we aim at achieving. We have three core robotics labs. The first one is the oldest one, which is the robotics arena. And you can see the video of the robotics arena. It consists of around 30 mobile robots, 3 humanoid robots, several drones, motion capture systems. The second lab is a new one, which is called as the SX Plant Innovation Center, which is where I work. And it is also the home of the Beast, which is a new robot which we recently built last year. And the third is a smart home, which is called as the iSpace. Okay. And recently we started 2 core degree programs in robotics. One is on robotic engineering and other is on mechatronics. So I'll quickly summarize what we are doing in these different areas: agriculture, healthcare, manufacturing, nuclear robotics, and how robotics connects to other disciplines. Okay. So let me start with agriculture. Probably some of you are aware. So these are some of the people with whom we are actively working. Some of you will be aware of the Tiptree Jam factory, Anglia Salads, NPL. So agri-food is the largest manufacturing sector in UK. Is around 108 billion pounds per annum, 3.9 employees, which is similar to larger than aerospace and automotive industry combined. But agri-tech is facing a large number of problems at the moment. The first one is the labor availability. So there is a critical shortage of labor for people who will do physically demanding tasks in the farm, and where robotics can help in terms of automation. There is aging population, there is political pressures affecting migration, economics, production cost, increase in demand. So if some of you might have noticed, as we are living in the COVID era, the government has recently launched this Pig for Britain campaign to encourage people to go and work in the farms, because otherwise there are fruits and produce which are rotting in the field. And it's a very difficult and a physically uh, tiring task and not financially rewarding. So this is where robotics can jump in. Okay. But I also wanted to particularly stress on the innovation in growing technology. So this is a Tiptree with whom I work, and you can see that this is the first of its nature in the country, where they have doubled the production. Okay, if you double the production, but if there is labor shortage to pick those fruits, then it's a very big challenge. Okay, so we are trying to solve these kind of problems in agriculture. So we built this new robot last year. This was the picture on the left is what we set out to design. It's a state-of-the-art platform with a very big mobile base carrying about 100 kilograms, two arms, soft gripping, a range of sensing technology. And what we do with this is to apply these robots to work in the farm to do a number of tasks. Okay. So the first task is computer vision, so identifying a wide range of vegetables, crops, fruits. Okay, and so you see in the picture in the right is basically estimating where the stem is. So predicting where the stem is and localizing it so that the robot can cut the stem. Okay, so there is a lot of work on computer vision, which is the what and the where part of the problem. Then comes the action system. So we are using a kind of a state-of-the-art neural network, which then goes and picks the strawberry. At the moment, the reaching accuracy is around 5 millimeter. But if you consider in agriculture, I mean, even products of the same type, there is a large variation in shape, size, color, and so on. And these are all products which are perishable and quickly damageable. So you need to use soft robotics to manipulate them. Okay. So we are working on both sensing and action. And then you see this. This is a 3D printed gripper and cutter, which can jointly grip and cut the strawberry. Okay, so some of this is starts from basic design on a paper. Okay, and then this is 3D printed. So the number of applications are fruit and vegetable picking, packing, which is a big problem. Intelligent control of environment, because you know that there is a lot of climate change which affects the produce. Farm logistics, so fleets of mobile robots, drones, monitoring of plant health. Uh, we just started looking at precision spraying. Okay, so just like the arm cuts the strawberry, if I can just precisely spray pesticides, then we can eliminate the extensive use of pesticides spraying everywhere. There are also some more projects using drones to detect black grass. This is another project which is on sensing of oysters close to Mersey Island. And we also do some work on 3D imaging of wheat and lettuce harvesting. So it's a big challenge in terms of both demographics, economics, and it's a big industry. And we are focusing on finding solutions to this industry. So just last September, we launched this new center called as SX Plant Innovation Center, which brings in computer science, life science, and data analytics together. Okay, so because agri-tech is a field which is truly multidisciplinary. In coordination with robotics and AI companies, growers, and students. So large number of student projects. I've just put the link below so you can get more information about the center. It's widely covered by media, the research in robotics in agriculture, and we also featured in the Future of Food 2020 report of the National Farmers Union. I've also put the link below so you can read this. It's a very, very good report on what are the challenges and how robotics can be of use in agriculture. Okay. So the next topic which we are working on is robotics in social care, and I usually like to use this word lifelong independence. Okay. And why do we need it? In the COVID era, we are already seeing a big shortage of caregivers, aging population, large number of people have mild cognitive impairments and they need care. It also puts stress on the family. So we need to minimize the stress on the family, and the cost of 24/7 monitoring is prohibitive. Okay. So we do a lot of work in collaboration with hospitals, and there are two challenges. One is making the robot live in a home, so which is the sensing, learning, acting loop. So we do a lot of experiments in the smart home. So visual spatial awareness, scene understanding, perceiving someone's action. So this is all the recognition from the robot. And the second aspect is interaction. So living, acting, and interacting. So interacting, this is just a project done by a final year student of mine. So this is setting reminders, okay? So for person with mild cognitive impairments, voice modulation. And this feature is the emergency call. So if the robot observes something strange happening in the home, it can call the family member. And imagine that something happened in your home and the robot calls you, and then you can instruct the robot what to do. Go to the kitchen, switch off the gas, something which I often forget. Okay, so you could just pick up your phone and command the robot. So multimodal interaction. There are also other things which we are working on, which is user modeling, because the requirements which I might need from a robot might be very different from what you might need. So customized assistance. Okay, one size does not fit all when you speak about healthcare. Auditory localization, sound. Most of the localization done today is through vision, okay, through eye, sound. And we also started some experiments in the new Crouchvale Medical Center. So this is something which we are very passionate about, healthcare in addition to agriculture. The third is manufacturing. So I just want to point out that Essex is third in UK in the number of knowledge transfer partnership with the industry. And so this is one example of adaptive motion control for laser cutting machines. So these machines cut any kind of thing, ceramic, plastic, textile. More recently, they are cutting gowns for the PPE, personal protective equipment, for caregivers during the COVID time. And we are trying to optimize the motion of these machines. Okay, these big robots, some of them are like 3 meter by 3 meter, some are even as big as a tennis court. Okay, so the picture on the left shows the motion of the robot when it cuts these kind of parts with knife, with laser, with pen, whatever you want. Okay, so I just put the link to the knowledge transfer partnership page where you can get more information about this. The next one is the National Center for Nuclear Robotics, which we are a part among in a consortium of around 7 universities. I just want to play a quick video. I'll just speed up the video slightly, but So the nuclear waste has been gathering since 1950s, and it can fill in a Wembley Stadium. So these are extreme environments that humans cannot go, okay, to act. You could visit the website of NCNR to get more information about the work they are doing here. Um, so after the NCNR, I just want to also say what students are doing. So we have creativity and product development mindset built in right from the first year. Okay, so this is a module which I teach, and we have a YouTube channel, first year students. And if you go there, you can see the kind of amazing projects which the first year students have done. There are around 86 videos already inside, and another 60 more which I will upload after the end of this term. Uh, Robo receptionist for the School of Computer Science, learning assistant for children, currency converter, Carobot, Ramsey bot, which is a chef, hotel receptionist, sports betting, airport assistant. These are all projects done by first year students. Okay, and if you go to the YouTube channel, so we actively encourage students to have a product development mindset, build something which is useful, impactful for the humanity. Okay, and this year what I'm planning is we want to do COVID related robotics projects, because we are now living in a COVID era. We are seeing so many new problems which need solutions, similar to problems in agriculture, nuclear industry, manufacturing, healthcare, which I already spoke about. So yeah, we want to focus on end user centric technologies. Okay. Once again, let's go back to the brain before I finish. So I asked you when I started my talk, imagine if Betty was a robot instead. So what I want to say is Betty had a brain, but when we try to build robots which can solve these kind of problems, we are actually reverse engineering the problem. Okay. So since most of you, I believe, are interested in robotics, I mean, if you consider most complex robots are a combination of mechanics, electronics, and software. Okay, so already it's a combination of three diverse fields. But when we try to make robots sense, act, interact intelligently in the real world, we engineers are actually solving the problem which the brain solves, to make ourselves act intelligently in the same environment. So this kind of understanding the brain and building intelligent robots are very closely related. Okay. So the take home message is, I mean, building intelligent machines and understanding intelligence are two sides of the same coin. Okay. On one hand, we have applications like agricultural robotics, healthcare, industrial robotics, nuclear. I'm also very interested in robotics in space and oil and gas. Oil and gas is still untouched so far. Okay. There is a big problem there, which where automation can solve. And on the other side, there are many other disciplines like biological sciences. I told you how plant scientists are helping us with plant health monitoring, productivity, soil analysis in terms of agriculture. We have psychologists who do experiments similar to the one I showed on Betty, infant cognition, results coming from brain imaging. And these two fields kind of drive each other. Okay, on one hand there is applications, on the other hand there is fundamental science. So this is what makes robotics a truly interdisciplinary field. Okay, so we can learn. It's similar to both building an aeroplane and flying it at the same time. We keep on learning constantly. So I just want to end with the Charlie Chaplin's eating machine. Uh, this is a very old video and I like it quite a lot. So we want to build also practical systems. Okay. And finally, I just put some more reading resources. So one of it is the Robotics 2020 roadmap of the European Union. If you see, it's 325 pages, but it is probably one of the most authoritative reports on what's happening in the field at the moment, what is the state of the art, and what needs to be done in the next few years. Okay. Similarly, there is the Factories of the Future roadmap, and the third is the School of Computer Science and Electronics Engineering webpage, which once again has a lot of information on the kind of work we are doing. So with this, I'll stop. I just gave you a summary of the work we are doing in agri-tech, healthcare, what are the challenges, nuclear robotics, manufacturing, and also the other aspect, which is to understand intelligence itself. Okay. So I leave it to you, Keely.